discuss about uh, about data visualization, and we are here to share my hands-on experience with you all, how you could make use of these plotting and visualization in terms of your expertise in or updating your skills in terms of your data visualization as well. It might be useful for your research work, and also it adds a value for your knowledge to handle your students in terms of a project. So with that, I'm going to start my presentation. So give me a minute. I'll be sharing my screen, and we'll start discussing. And I request everyone to be more interactive. And at any point of time, I'm so grateful if you have any questions. Right. So I don't mind at all, even if you interrupt when we are discussing. So rather than kind of uh, you know teaching, and I just want everybody should collaborate and participate in this discussion. I need, or I want, I wish this session is going to be a more discussion rather than you know one way of delivery. Hope you all got to understand, and give me some time. I will share my desktop. First, I go with slide that I have been prepared. Give me a second. Yeah, yeah. So um, visualization. I think when we heard a word called visualization, what comes in your mind? If I get any inputs, that makes sense. Visualization. So it's a visualization. It's a visually you are going to looking someone, all right? So you'll be understanding uh, what is the pattern of that vision, right? So let us take vision as two way, as a human, as a computer. As a human, how we looks picture or anything, right? So a human vision is something unimaginable, right? Lenses. Right? So automatically, because our human eye lens are very adaptive and very dynamic, right? So even we cannot compare our human vision to the computer visions. So and most of the people are today or researchers are today working on human vision or computer vision to make some sensible insights to be in the production. But still, we have not yet developed, or even we have not yet completed 40% of the human vision lenses. That is very unique and special things. But human lenses are connected to the brain, human brain. Whatever you are looking, that has to be processed and that is going to be stored at your neurons. That makes sense to when you get something else. So, vision is to understand, because I'm not gone into very detailing about the human vision and computer vision, because since that was the that makes that will be debated our topic, so that I directly go on to the visualization. So when you look at somebody else without knowing their faces, also you might be referring for is that person, is this person, right? So how do you identify it by looking some some pattern of your your neighbors or friends or relatives or whoever it may be. You are capturing the patterns, right? So this pattern for this person, as such, your vision as identified and classified, right? Our human vision is very intelligent classification, a model which is running inside it, right? That is what we are trying to bring up into the computer. Okay, so by visualizing something, you are trying to understand the nature of the pattern or the perspective. You are trying to understand the perspective of that, you know, image or person, right? Image and person, I mean, it is an information. So, using the visualization, uh, when you want to do analysis, anything, we want to capture the interesting things which has been done in the information. So, in a nutshell, I can say visualization is a kind of a thought process by which we are learning or understanding the nature of the data. So, it is I could say it is a thought process. Thought process which helps you to try to understand nature of data. All right. So that is the objective of this visualization. And you may ask, you may put up a question like, why do we understand the data? What is the necessity? See, once you completely understanding, then you may be able to recognize, right? So if you, when you are, seeing somebody, if you able to understand the pattern of that person only, you may call it as a, K.Pradeep or Hey Ram, something like that. You may referring, right? If you are not able to understanding the pattern, then how come you refer as your friend? That is very difficult, right? So when you are understanding the nature of data, then it is very easy to take it forward in the next level, whether that is because once you identify that person only, you will be calling. If not, your brain is your brain is taking a decision by looking the feature of a person's. If it is not matching, then your brain says you, hey, don't call him because since he is not your friend. If some data patterns are matching, then your brain is taking a decision. Yeah, he is your friend. Just call him. Right. So that is the interesting derivatives that we can take out from the visualization. Hope you all could understand what is the necessary. Okay. So any difficulties? Because I got some messages. No problem. Is my voice and screen is visible, right? Yeah, ma'am. Thank you.
Sir, it's audible and clear, sir.
Okay, thank you, thank you. Because somebody puts a message. No issue. So, what is the takeaway of the session? We'll be learning about Matplotlib and Seaborn, and the next thing we are going to have some hands-on demonstration on it. And using the pandas also, I do some basic hands-on, right? And Seaborn, with the help of Seaborn, we do have a demonstration. And finally, I do take some case studies. 1 minute, please. Okay. Yeah, I've joined. Okay, sorry for it. So, as I just before, and as I said before, data visualization is used to understand the uh, nature of the you know internal pattern of the data. To do that, right? To do that, you need these skill sets. You need statistics. You need machine learning. All right. So when you want to, so if you have a data as like this, just a minute, I'll take it Microsoft Word. So you need to take, so you take this information, A, B, C, right? So there was the information was stored in all the way, but we want to summarize it. We want to summarize it. What is summarization? So summarization is we need there are basic statistics by which we can summarize the information in terms of a statistical way, uh, like what is the you know minimum value, what is the maximum value, what is the total count of the you know records, and what is mean, what is standard deviations. So these are all the very important statistics, which is very necessary to summarize your what is that to summarize your informations, or I may take data. All right. So I'm going to add some of the statistical elements onto this basic statistics. This is actually 25% of data belongs to what level, and then you have 50% of data belongs to what level, 75% of data belongs to what level, right? So this is what we used to call it as a quartile 1. This is what we could call it as a quartile 2. This is quartile 3, and the gap between these, right? First quartile to second quartile, that intermediary, I'm going to call I'm going to call it as a interquartile 1. People used to take IQ1, interquartile 1, 50 to 70% interquartile 2. IQ2. So these are the value: mean, max, count, mean, standard deviation, IQ1, IQ2. So these are the basic statistics we need to know to summarize your information. What summary? What is the summarization? Whether whether the data has linear relation or not. Then it will be checking whether the data has the correlation, right? What is the data distribution pattern? What is the data distribution pattern? Whether the data has the data has good or bad news, right? Then the next summarization is, can we take it forward to the forecasting model or not? That's it. So this is the takeaway about the data visualization summarization. Give me a minute. Sorry for the interruption. There was an audio issues. Okay. So this is actually a takeaway. This is what the summarization. This could be decided by visualizing the data, by making the graph by which we can able to understand how the data distribution is going to be. So that is what we need as statistics and machine learning. The machine learning is a kind of uh, algorithm by which we try to train the model to forecast it, right? To predict whatever you want it. So uh, for data visualization plays a vital role in terms of forecasting model building. For that, we need statistics, and with the help of the statistics, we will be finding the pattern and the nature, distributions, everything, and it gives a clear idea about it. And sometimes the visualization can be called as a EDA, exploratory data analysis. By just simply exploiting the information in terms of a graph, we'll be finding the interesting pattern in it. So that we technically will be naming it as a EDA, right? Exploratory data analysis. So here we are going to talk about line chart, bar chart, histogram, plot, scatter, and I'm going to add some of the plots like joint plot as well as what is that, strip plot and pair plot and etc. I'm going to demonstrate you all in addition to these are the very basic like line bar histogram and all. I think box and whisker plot are quite different for your understanding. So I'll tell you what is the box plot. All right. And as well, you could see here identifying patterns. You know what is the patterns I've told you. Correct data, right? And outliers. Outliers are nothing but it is a noise. What exactly the noise is in it? So let you take the employee salary. That is the some data. The salary is going to be 10K and 15K and 20K. It is quite natural. Suddenly you just I can get your 350K, right? So here when you are looking this information, 10, 15, 20 are the data which are in the same range of values. Whereas 350K, what is 3,15,000 is the salary, which is abnormal salary of each of the salary items, right? So when I could find abnormal or when I could find uncertainty, I could I could say it is an outliers, right? So outliers are nothing but noise, right? This is what no, your normal range of data, normal data range, which is abnormal, 350K, which I could say uncertainty. Uncertainty, uncertainty can be referred always as an outliers, right? That's it. Okay. So now we will be take forward into the EDA. What is actual objective? As I said before, we do analyze visually. As I said before, we are going to summarize the information what you have in your file and detect anomalies. Anomalies are, I could say, uh, outliers, or you can say noise that is going to be identified and should be eliminated, right? And visual patterns and trends. I hope you got able to understand what is the meaning of all these points. All right, let's come here. Uh, what is the life cycle process of the, the entire data science landscape? So you have problem. What is hypothesis testing and data visualization? And you might be wondering what is the hypothesis testing, because what you are going to get out from the data visualization, same thing you are going to get from the hypothesis test. Hypothesis testing is nothing but pure statistical, right? Pure statistical testing, wherein you are trying to understand the nature of data, right? Similarly, what is the outcome of data visualization? What I have been told in terms of data visualization, same thing. But I'm not going to create a graph in the hypothesis testing. Instead, I will be calling the statistical methods to test whether there is a significance in the data or not. Say for an example, is that test, cheese test, cheese square test, F test, and P test. So it's all the hypothetical testing, right? What is actually hypothesis? So hypothesis is something whether with this data could you able to deliver or could you able to derive any meaningful insights or not. All right, that's it. So hypothesis is nothing but it's a kind of a, situation wherein which the data would be helpful for you or not to come up with your expected outcome. Right. So to able to understand the significance in the data, we have to perform all these tests to know the name, to know the data distributions or anything you can say, data distributions, etc. So, so, so you you can you can you can always get the summary of the information with the two way. One is hypothetical testing and data visualization. Now, data visualization is more easier than the statistical way of approaching the data, because the one who knows the mathematics background, or they were very strong in the mathematics, they'll go and approach the data in terms of a statistical way. The people who are not good at mathematics, the people who are much knowledgeable or much curious about the graph, they'll go with the visualization, right? So with the visualization also you could get everything. Right? So once you've done the visualization, this is what actually technically called as an EDA, and why you are going to select the model. The model selection is nothing but if you find this data is more significant or more useful, then you go and build a model. And this is what model building. Model is in forecasting model building. So here you have to choose an algorithm. You have to choose the right algorithm to make a forecasting model for this data, what you have been tested. Right? So then you could find the better performance, right? You will find a better performance. When you want to get a better performance, you have to fine tune the model. The fine tuning is a kind of a heuristic approach. Heuristic approach. What is actually heuristic approach is a kind of a mechanism wherein which you have to fine tune the hyperparameter, fine tune the hyperparameter. The hyperparameter is a kind of a parameter wherein which you can improve or you can boost the performance of your model. So uh, when your data is good, then only all the process are going to be done. Alright. So generally, I could define your entire machine learning or data science lifecycle into three parts. One is pre-processing data, pre-processing model building. I could say pre-processing or pre-model, pre-model, anything you can say, pre-model and post-model construction. Right? You have the entire machine learning life cycle can be divided into these three parts. Alright. And 35% of the effort has been given to this pre-model. Similarly, 30%, and here also 35% of the effort has to be given in the model building. So why I'm trying to give this uh, right. Okay, so uh, this much important for the pre-model, this much important for the post-model, this much important for the model construction. So equally important as how you are going to deal with the algorithm. You know, that's what we are going to look into the PDF. So now I'll take into the uh, some hands-on just a minute. So I'm going to start with the demonstration. With that, I'll explain all the graphs and what is the takeaway of each and every graphs. Give me a minute. So I hope that you know the libraries because I'm not going to discuss or explain you the libraries. All right. I'm going to import the NumPy, which is required for us. So I'll be importing, and I'll be importing pandas, and I'm going to import the visualization graph Matplotlib. Alright, so these are the four packages we must need it to work with visualization. I'm going to execute it. So now your this star indicates like the packages are importing. We'll wait for a while. Similarly, you could find there is a globe symbol, right? So if it is there, it is processing. So till then, you shouldn't disturb your environment. This is the Jupyter environment where in which you can write your Python code, right? So when you want to get this kind of environment, you have to install the Anaconda Python. Anaconda Python is a framework or it is a package. You just go and download it, and once you install, you will be getting a Jupyter framework. So I think you might be knowing the framework how you are to install it. Else you just Google it and you'll get a lot of steps to install and make it use of it. So we'll wait for a while. Give me a minute. It is still importing because rather than explaining a theoretical way, it is much better I think. So if I do take outcome and if I do plot it and then with that if we discuss that makes sound. So just wait for a while. It is loading. Yeah. So it has been imported. So now I'm going to get some data. I'll show you. So PD is nothing but pandas. Pandas dot. I'm going to read a Excel file. So I'm going to call this module, and I'll just take the file. I have to paste the path of the file. I'm going to take the file. Just a minute. I'll be taking. I go to this drive, and there is a folder data set, in which I'm going to use the automobile. Right, I'm going to copy this. Let's see whether there is an automobile. There's a data set called automobile. All right, so I'll paste here. That's it. And after that, I used to say automobile.csv. That's it. Now all your information was mapped to this object called data. So if I enter this data, you could see here, it will be listing out all the information in the data. Right. That is the power of pandas. So if I put it, it will start displaying the top 5 rows. Right. So you have a lot of information. As you can see here, I'm going to show you what is the metadata information about the files, data. I put info command, it will show you all the metadata information. You could see here 201 entries and index starts from 0 to 200, and the feature name, the column names are symboling normalized losses to make fuel type, aspiration, number of doors, etc. And count down. Totally, how many features are there? 0 to 25 to so 26 columns are there. And among the 26 features, 7 features are floating value, 9 features are integer, and 10 features are object. The object is nothing but string. As you can see, right, make is nothing but Alfa Romeo, and number of rows 2, 3, something like that, right? So you have certain features or string. And keep remember always one thing in a data science, the string features cannot involve in the analysis. So it has to be converted either in terms of a numeric, or else those feature has to be rejected or eliminated by the analysis. So out of the 26 features, 7 plus 9, 16 features are the number based, 10 features are string based. So only 16 features are going to make use of the what? Your analysis. The string is not going to be used by an algorithm, but you can make visualize it. You can count all you can apply all the graphs over the string features too, if it is a categorical. All right. So now I'm going to get a summary for that. I've told right statistical summary. describe. Use the command called describe. It will get a statistical value for all the columns. You could see, as I told you right before, statistical basic statistics, the count, mean, standard deviation, minimum, 25 percentile, 50 percentile, 70 percentile, maximum value. All right. So once the data are loaded into here, the pandas is calculating all the statistical values defaultly. Whether you demand it or not, the pandas are calculating and keep it inside it. So whenever the algorithm meets the minimum value or maximum standard deviation, it the algorithm won't ask you to give me a mean value or give me a standard deviation. Instead, it will go to the pandas and from there it will take it out because all the values have been pre-computed and it into the metadata. It will take it. That is the advantages. All right. So now we will take something, right? So data dot I put tail shows the last 5 years. Right. I'm going to we are going to take out the numeric data features, which is the numeric value. I can take stroke, bore, engine size. It's all the numeric. Right. I'm going to um, create a scatter plot. How do we create a scatter plot? SNS. SNS stands for Seaborn and call the scatter plot, wherein which you have to pass the two features. The first feature I'm going to put bore, right? Bore of engine, comma, data of the stroke of the engine. So what is the distributions that I could able to find it in these two features? As you can see here, the scatter plot, right? So this plot is, when you are looking this plot, the data points was totally scattered in all over the bore and stroke mathematical axis. So the outcome, what is the inference here is like the bore do not have the much linear relationship onto the stroke. All right. So it has the partial relation, partial or which has the very least relation, bore versus stroke. That is the inference we can take it out. And before that, I could take, I'm going to take out some information out of it, df equal to df of, so I'll just copy some of the features to make you better understanding. I'm going to, what I'll be doing, taking 1 minute, bore stroke right. I can simply type. And then pick RPM. I'm going to randomly take to demonstrate. Pick RPM 1, 2, 3, 4. I think it's quite enough. And do we have any other features? Let's let's take rice. Sorry. Then I can take. I may choose another features. Fuel type. I may take fuel type. I may take a fuel type. I may take a fuel type. 1 minute. Okay, fuel type. I have taken only these features. Okay. So we are taking the features as like this. Y df equal to, sorry, here we have to put data. So now I'm going to display the data, sorry, df. I've taken small data set, right, to make it happen. Now I'll be converting my fuel type in terms of a category, because since it was a string features, I want to convert as a category features. I'll be converting as a category. So to convert fuel type as a category, I'll be taking df4. The feature name is fuel type. DF is the subset of the actual information data, because it has 26 features. So if I make any graph that you can't able to understand it, so that I'm going to slice only 5 informations, 5 pieces, 1, 2, 3, 6 features information. With that, I'm going to demonstrate you how the visualization is going to be happen, since you can able to understand it, right? So fuel type, I'm going to take it. I'm going to convert as a category, right? df of um, fuel type. Fuel type dot as type of. That's it. Okay. Now I have, right. So now I'm going to call the pair plot, right? Or else we first I'll just get you the correlation graph. What is a correlation? I think you might be knowing about it. The the correlations. So correlation is used to identify the linear relationship in your at your data. All right. Let you take, there are 3 part of data. So if your data was like this, and if your data is, it's being like this, and if your data was distributed as like this, right? Let us take, this is x and this is y, x and y, this is x and y. You could see here, if x increases, if in x-axis, if you have the x value, right? If x increasing, y are decreasing. Am I right or wrong? So if x increasing, proportionately y are decreasing, right? This is what negative correlation. Negative correlation. If something is increasing, other parameters are decreasing. And you can see here, you cannot say increasing or decreasing, right? Since your data point was scattered all over the x and y region of the mathematical space. So I could say no correlation. We cannot find anything. And similarly here, if x increasing, y is also increasing, right? But x increasing, y is also increasing. So this is what positive correlation. So which data is much useful in it? The next question is whether the uh, positive correlation or negative correlation, which data is useful for the model building. All right. Because at which at which structure of this data distributions there was a fluctuation, that is much useful for us. So at which point there is a fluctuation in positive and negative correlation, there was a changes in it. And in the mid, right, you don't have any changes, right? So something like that, you could take a ECG signal. When the ECG signal goes ups and downs, the person is live, which means the data is live. When the ECG signal goes as a flat, then there was no changes, right? And he is no more similar to that. So the coefficients are going to be measured as like this. The numeric values are going to be -1 to +1. This is 0. So if you have a negative correlation, that is good. If you have positive correlation, your data is okay. With that, you may come up with any meaningful insights. But if it is have a 0, if it is a no correlation, you cannot get it anything from the data. That is a dead data. Don't take it forward to the next level of the process. That is what this no correlations. So here, with my experience, I may split the ranges. All right, what is the ranges? So minus 0.22 plus 0.2, you consider it as a 0 because you have very least correlation. So consider 0. There is no correlation. This is what. After that, this sum level, right? This is what zero point 0.8 and above. This is what also in terms of a minus zero point 0.8. Right? This is strong negative correlation. Minus zero point 0.8 and above, strong negative correlation. This is strong positive correlation. If you get a correlation value zero point 0.8 and above, similarly in negative side zero point 0.8 and above, those data are much useful for you to or to build any forecasting model. So in between, right, there is a 0.3 to this is moderate correlation, somewhat okay, but you cannot deny this. Right? Similarly, this is a moderate. Right. So this is no correlation. This is waste, dead data. No, there is, you shouldn't use it because even if you use this data, if the correlation is minus, close to 0.02, then you cannot create any good forecasting model. That model won't be working good in real time. So this is the way you can understand out of the, what is that, correlation matrix. So this is the value. You can see this is the value. 0 0.0, 0 0.06, 2.1, 2, 0.54. You have something, you have the very only certain features as the moderate correlation. You couldn't find any better correlations here, right? There is no 0.8 and above, or moderate as well as the close to 0, right? So I may convert this graph in terms of a, sorry, this correlation in terms of a graph. SNS dot heat map of df dot, you know core annotate equal to true, and v vertex minimum equal to -1, vertex maximum equal to +1. If I call, you could find there is a graph is being created for the correlation matrix. So the people who are doing a research, you can take it this graph and you can put, you may use into your research article. So that makes a value onto, that makes a sense onto your research articles. Even a project, the people who are doing a project, you can, because if you do visualize, you can do put a graph that makes sense rather than just writing a statement, right? And then I may take a pair plot, df dot. So pair plot is nothing but multivariate analysis. At a single shot, you can create a multiple graph for all the pair of the features. So I'm going to call upon the pair plot, SNS dot pair plot of, what is that, df. You could see here it takes some time to generate a pair plot. Since it is a multivariate analysis, you could see here this is pair plot. At a one shot, multiple charts are being built where in which you can identify what is the linear relationship between the features. All right. So this is what a multivariate analysis. All right. At a single shot, you could able to get the outcome. So now I'm going to build a. I'm going to take 1 minute. I'll take another data because it has huge one. So I'll be taking another subset of data to make it DFF. So here I'm going to remove the two features. Right. Okay, fine. One, two, three, four. So let's take DFF. I'm going to put SNS dot parplot of DFF is the subset of the DF. So you can look at it, but rather than this, I'm going to do that SNS dot parplot of DF comma U equal to U in the sense with respect to some features, you just make a plotting. All right. So not DF, it's DFF comma Q equal to DFF of fuel type. Based on fuel type, just make a graph. Since it is not a, it is a string, right? So it is not supporting. It is a string. That's the reason why it is not supporting. So no problem. We'll go with another graph. So df dot, you can find histogram, right? So histogram, you know what is an histogram? I put 10, come on, right? Give me a minute. It will create a histogram. You could see histogram is a graph wherein which you can able to identify or capture the density of the records of each and every features. What is the density? All right. I think you might be knowing density in the sense. For example, there is a, let us take a price, right? So price 10,000 to 40,000. So all the vehicle prices, the most number of vehicles prices are going to be 10,000. You can see here 80 vehicles has the price is 10,000, right? And the vehicle prices is not, the data doesn't have the evidence for the uh, 30 and above, right? You have a very less number of records that belongs to 20,000 to 40,000. So the most you have the larger number of records supports to the price is 10,000 to below 10,000. That is the larger value. So it gives the density, right? Oh, the density is nothing but the number of records for a particular value. That is the density. So this is what you are histogram. We have done parplot and everything. Now I go with some kind of line plot and all. 1 minute. All right. So histogram scatter. I go with the joint plot. So SNS dot joint plot of, joint plot is nothing but I'll show you joint plot of DF, or I'll take data of what? Uh, Engine size. There was a feature called engine size, comma, data of horsepower. Right? Engine size versus horsepower. These engine size horsepower is the features which is in the actual data. Joint plot is no. You can have a look onto it. Give me a minute. Yeah. This is the joint plot. What is actually joint plot? I'll just copy and put in the, and we put over here. Okay. So not here, I could put into this notepad, it will be fine. It's not supporting. Yeah, you could see here, this is actually, I could choose it. This is histogram. This is histogram. What is this one? This is scatter plot. So in x-axis, you have engine size. In y-axis, you have horsepower. So what is the relation between engine size versus the horsepower? That is demonstrated by the scatter plot. This is right. And similarly, the density, the histogram is you know it's conveying what is the density of the records of these two features. That's what these histograms are saying. So in a one shot, you may have a two sort of outcome, a two sort of insights. That is what joint plot, right? So joint plot is a plot wherein which it combines histogram and the scatter plot, and it will be displaying in a one single shot. You may have an idea about the relationship as well as the density of the records of a particular features. That looks nice, right? So now I go with the next thing is I go with what is that? We go with the same joint plot in a different way. SNS dot joint plot of same data of, I could go with same engine size. You can use any features. Horsepower, right? Engine size. Oh, sorry, we have to put data of horsepower. And here you have to add one more parameters, kind. Kind equal to, I may say X. The sense X stands for hexadecimal, which means that all your data point is going to be displayed in terms of a hexadecimal representation. That's it. Not hexadecimal, hexagon format. You can see here. So here, instead of point, your data point was displayed in terms of a hexagon shape, all right? So similarly, the colors, the thick colored represents at that particular point the data density was very high. The colors goes lighten, which means that data density is going to be very less density, all right? That is the uh, graph, this one. So you can choose the kind as like this. And I may, next one is I'm going to demonstrate to you as a kernel density estimation. I'm going to copy this one again. I'm going to paste up here. So just I'm changing the kind equal to KD. KD stands for kernel density function. All right, it is a kind of a mathematical notations, based on, you can see here, this is the kernel density graph, right? So I can copy and I can put, I can try to explain. One minute. Yeah, this is the kernel density function, KD. So what is kernel? This is the kernel, right? So you could see here in this point, you have a thick color, right? So density is high. So then when comes here, the colors are lightening, which means that moderate density. This part is very, very light density. Similarly, your histogram is going to be given as a density, based on density, all right? That's it. This is what your kernel density estimations a graph. So now I'm going to do the same thing with a strip plot. SNS stands for Seaborn. SNS dot strip plot of what? So data of, I'm going to give fuel type versus horsepower. Any features you can take it up. All right, that's it. We can see a strip plot. So you have a two features, fuel type. So what is the variant in the fuel type? You have a gas variant and diesel variant. So in a gas and diesel, what is the horsepower? You could see here, the horsepower is very high in the gas-based vehicle. In a diesel, the horsepower data distributions was very less. All right, that is a strip plot. And same thing, I'm going to do in the swan plot. So swan plot is similar to the strip plot, but where in which we can exactly find out the at which horsepower the density was very heavy. It will show in terms of a shape of the swan plot. You could see here. So data of I could say same fuel type. Come on, data of horsepower. All right, that's it. So swan plot is done. So you could see here. It's done. 1 minute. Okay, sorry for the interruption. So swan plot is exactly depicting because you can see here at which arch core density was very high, it will be exactly representing the data distributions. So, and then you go with the box plot. Box plot is used to identify or figure it out the noises in your data, whether your feature has the noise or not. Already I have told you the noise is nothing but the outliers. Whether do we have a outliers or not, right? So I'll just do put the box plot, SNS dot box plot of data of, we can give anything. I'm going to check R score. You can see this is the R box plot. So the data point which you have, it's all outliers. Right? I can copy and I'll just demonstrating you. Yeah. So this is the R score, right? So these are the data point or the outliers. This is outlier, outlier. So I could say noise. All right. How the noises are calculated. All right. So this is the box plot. This is the minimum value. This point is the first quartile, 25% of data. This is mean or 50% of data. All right. Sorry, mean. Oh, sorry, this is only mean. This is 50 percentile of, sorry, this is 50%. This is 75% of data. This is the max value, not max actually. This minimum and the maximum is decided by the normal distribution curve, by the normal distribution curve. What actually the normal distribution curve? You could take it, right? If you take this is the thing, you could see here. I think you might have been noticed this kind of graph. This is what normal distributions. So this point is mean. I kept saying mu. Mu stands for mean, and I could say this point. This is what mu minus 1 sigma, mu plus 1 sigma. In this ranges, 65% of data was distributed. This was the statistical way of approaching. How? Because it was defined one. All right. So if you call the data distributions curve, and if it clearly matches with the normal distribution, in this mu minus 1 sigma to mu plus 1 sigma, 65% of data. Let us take this point, mu minus 2 sigma, this to mu minus mu plus 2 sigma. In this ranges, you'll be covering almost 90, I think 95% of data. mu minus 3 sigma to mu plus 3 sigma, you'll be covering 99.9% of data. So mu minus 2 sigma to mu plus 2 sigma, almost 95% of data are covered. So depends on the places about the statistics. This point might be a mu minus 2 sigma. This point is going to be a mu plus or 2 sigma. So this defines your boundary level. And after this point, if any data are distributed, this is abnormal value. As such, the statistics are considering. Right? As part of the statistic consideration, we could say these are all outliers. Outliers are, you can say in another words also, extreme points. Anything you can refer, extreme point or extreme values. Right. So we should calculate or find out whether do we have outliers in our data set or not. If you have more outliers, then we should rethink it and whether can we retain the outliers or not. Okay. So as such, you can create a box plot for all the features. You have to look and observe, get inferences about each and every features, whether the feature has noise or not. So I can plot it for another features for your references. Data of, let us take fuel type, not this big, fuel system or anything. Oh, it is a string, right? For string, it will be coming up. I could put price. So we have many outliers in it, right? And then you can have the box plot for more than one feature also. SNS dot box plot of, okay, I may put data of number of doors versus, right? So ask power, anything you can put. You can see here, this is the outliers chart for comparing two features. With respect to, what is the outlier for number of doors with respect to ask power? All right. Similarly, I can do it. Okay. So I can create one more thing. SNS dot box plot of data of, I can take same features, number of cylinders. Let me take number of cylinders, comma, data of, I can take horsepower. Now I'm going to say with respect to another features, what was your outliers in the two features? So for that you have to set U. U stands for based on which feature you want to filter it out. So I want to based on the fuel type, I want to find out the uh, outliers of it. You can see here, all right, number of cylinders. Similarly, I can copy this, I can paste it. All right, instead of number of cylinders, I may put number of doors. You can see here, all right. As like that, you have to get the outliers for all combination of features. You have to do it one by one. All right. Now even you can get a bar chart, right? Bar plot of data of, what is that? I may give the body style, comma, data of, what is that? Horsepower with respect to, I'm going to set the hue with respect to fuel type. You can see a bar chart. So that the black color lines are all the outliers, right? So where the outlier starts, right? So because even you could create this in Excel also, you have to do a lot of configuration and all, right? So which is very simplest way of doing it. And then I'm going to like count plot. See, whenever you want to count your variable, your values in your features, you can go to the count plot, which is very easy. All right, I'm going to count plot of what is that? Fuel type. I can take fuel type. It's very simple. How many fuel types? I have gas and diesel. That's it. In gas 175, and diesel you can see the respective Y value, that is count. So SNS dot count plot, I can put into the other features, data of body style, the style of the car with respect to fuel type. You can see how the plotting is going to be done, right? So similarly, you can do it for a, there is another thing called a point plot. I'll do that. So point plot of data of body style, comma, data of, I'm going to get horsepower with respect to what? Let us take any features with respect to uh, fuel type. Similarly, fuel system or fuel type. This is the way the point plot are going to be generated. Right. So these are all the very important visualization aspects, and each and every graph. What will be the inferences? That is very important. Just not. It is not important to just plot the graph. It is very important to infer what it is conveying. That is very important. So in each and every graph, you have to understand something about the nature of your data. So then after plotting all the graphs, if you find the data is good, then take it forward into the next level to construct the machine learning model with the help of the algorithms. Then you can create a forecasting model. Right. So that's it from my side. Let us go with the QA part. If you have any questions, I'm here to answer you all. I'm very happy. I'm very glad if I get some good questions. Can I get any questions? Participants, if you have any questions, you can ask me. Please let me know if you have any questions. Organizers, are you there?
Going, sir. Karthik here.
Hello, sir.
Okay, participants, give me a minute. Let me call organizers and yeah, sir. Yes, sir. Tell me, sir. I have done. Sir, can you hear me, sir?
Yeah, I can hear you, Pradeep, sir.
Sir, Karthik, sir.
Yeah,
Can
sir.
you
Yes,
hear
sir.
me
I
or
can.
not?
Yes, sir. Sir, tell
Yes,
me
sir. I
when.
have done my part, sir.
Okay, sir. Okay, sir. Please
Yeah,
begin.
sir. I have done my part. If audience has any questions, let us answer.
Hello, sir. Pradeep, sir.
Hello, sir. Can I ask question, sir?
Yeah, yeah. Yeah, I'm here only, sir.
Sir,
Please, of
yes, sir.
course,
Sir,
I'm waiting for
my,
that.
my question, yes, sir. So my question is, how we can find the correlations between variables with this any way?
Sir, 1 minute. Your voice is not audible. Uh, can you repeat your questions again, please?
Yes, sir. So my question is, how to find the correlations with this correlation values, positive correlation, negative
Sorry.
correlation, that thing. How do you find the correlation?
See, I'm very. Yeah, please come again. Come again, please.
Sir, my
How
question
to
is
find the
about
correlation
finding
of the
the
variables,
correlation.
right?
Right, sir. Right. Within the variables. Yes, sir. Input output variables.
Okay. How to find the correlations? Okay.
Hmm.
See,
Yes, sir.
if you take
Ah,
if you take any two variables x and y, right? So there are certain mathematical formulae. So correlations of x and y equal to, right? So there are certain mathematical way of representing. You have to put all the values here and you will get the correlations. So how to get a correlation is a complete mathematical way of solving the problem. Because I don't want to. You don't need to know how that correlation are going to be valued. You have to know it with that correlation value what you are going to understand. Can you? Sorry. So can you get it or not, sir? Please.
Yes, sir. Yes. Got it, sir. Thank you, sir.
Okay. The formulas are available. Even you can get it. The formulas are very simple. You can get the formula in a web or else you can make use of this formula. So correlation coefficient usually can be referred as R. R equals summation of xi minus x bar and yi minus y bar. So x and y are nothing but the mean value. X bar by square root of and summation of y minus y bar, the whole square. That's it. So using this formula, the correlation coefficient values are going to be computed, and and with that what you are understanding, that is very important. So this will give a idea what is the linear relationship between the two features. That's what I have told you. You have the range of values. You can refer that one. Okay. Any other question, please?
yeah, sir, Pradeep, sir.
Yes, sir.
Yeah, sir. Myself, Manivanan, sir.
Sir, can you hear?
Hello,
Yeah,
sir.
tell me, sir. Money, sir.
Yeah, sir. Can you hear me, sir?
Yeah,
Hello.
I can hear you, sir.
Okay, sir. Okay, sir. Yeah,
I can
participants,
hear you, sir.
if you have any questions, means please unmute and tell, or you put in the chat box. Okay, sir. Shall we wind up, sir? Hello.
Sure. We can wind up, sir.
Okay, sir. Okay, to
Yeah, we
propose
can
a
wind up,
vote of
sir.
thanks for this wonderful knowledge transferring presentation. On behalf of St. Joseph Institute of Technology, Tripoli Department, I extend a very hearty vote of thanks to the Honorable Speaker, Mr. Pradeep sir, who shared his valuable real-time knowledge about the presentation by his thought-provoking things. And I also express my special thanks for accepting our request on wonderful presentation today. Thanks a lot, sir.
Yeah, thank you very much, sir, for the great opportunity. uh, to be delivered as a system.